Okay, good morning to everyone. Thank you for staying in the room. Um, myself, I'm Bruno. I'm professor at the University of Coimbra. João has concluded the master. He was also working in the project in the reputation system, and he's still, let's say, helping us in more features that we also need to implement. We will mainly provide a motivation for this component. Um, then the integration in Arcadian IoT and how we enable, let's say, the reputation system. So, first of all, we need to have an idea of what is reputation, because normally we use this term in every day, and it's, let's say, if we go for a definition coming from the dictionary of Oxford, we see that it's the opinion that people have about someone or something. And this opinion, let's say, um, can be taken into account considering what the information that we have, or let's say previous interactions which allow us to provide good or bad reputation. And of course, this can change over time or according to a specific event, and so on. And we always also associate reputation with other terms. We saw, for instance, in the previous presentation, the term trust, the trustworthiness. And here in this regard, reputation is always associated, let's say, with these two terms, with trust, and mainly, if we see some definition, the trust is, let's say, the reliance on a system or on a specific surface that it will behave as it was designed to. And of course, we can measure this in certain terms, because we can have different trust levels and so on according to the probability of reliance. On our daily usage of applications when we are installing and so on, this is just a screenshot from Google Play. So we see reputation, let's say, in a 5 stars scale. And normally we use this information for what? For mainly judging if we should install or not an application. So this is just to alert that we always use this information. Inside Arcadian IoT project, uh, we have, let's say, an architecture in the Arcadian that is divided in different planes, and we have the plane for trust. And of course, we need, let's say, a station, as my previous colleagues presented, and the reputation system, and which also we have also other components like the authorization, mainly to make decisions regarding which device is authorized or not to access to a specific resource in the network, and how we identify the identities. Also, in the project, we have also, let's say, a concern regarding different types of entities. So we have persons, we have objects, so IoT mainly, and also applications or services. And on this regard, the reputation system is mainly dedicated to what? To present, let's say, to formulate a score for a specific entity, either a person, for IoT device, or a service. And this also introduces some challenges on our side, because we have different types of entities. So we need somehow models that can work with this type of entities. And on this regard, what we have started, let's say, the starting point was the alpha beta model, which works like a binary logic. So we assume that we have positive events, so those that affect positively reputation, so that contribute to good reputation, and those that contribute to bad reputation. And according to the alpha model, let's say, and the formulas that are here in the slides, we can establish a reputation score based on these simple categories. So having positive and negative events. On the other side, we also need to go further because sometimes events can have also a severity. So, for instance, if we see a negative event, and this, let's say, corresponds, for instance, to attack that was successful, or to an event related with the security that has a high severity. And we need to take into this account this information. And so that's why we have also another model where we consider the severity of the event that is generated. So this model is mainly based on the alpha beta, but we rely on the severity. And to rely on the severity, we also use a specific scale that is used, let's say, in the literature. So where this severity, let's say, can vary in specific levels. So, for instance, between 1 and 3. Both these models, so the alpha beta and the alpha beta with severity information, work for all entities as soon as we have this information. We also have another model in the reputation system that is the dominance, which is mainly based on what? That considers the input from users. So, for instance, coming back to the previous slide, those 5 stars that we give for a specific service, for a specific application, we take into this account. And to avoid, let's say, to be able to aggregate that information into a score, we use specific formulas to consider the overall opinion. So aggregating the information from different users into a score. Of course, this model requires input from the users. That's why we can only apply this model when we have user feedback. How we enable this in Arcadian? So simply, in the reputation system, we have mainly 2 components. So the policies, which are related, for instance, that are required for the authorization and for the attestation, and that establish a mapping between the reputation score and a specific action that needs to be taken. And of course, the reputation system itself, so which runs these mathematical models that I was sharing, so to determine the score. Additionally, the reputation system also communicates with several components in the Arcadian project because we need to gather information. So what is happening regarding specific devices, specific services, or specific persons, so that we can establish a reputation for these entities. In addition, we also interact, let's say, with the blockchain, mainly to store the information related with the reputation scores, so that this can also be used by other components that want, let's say, to gather knowledge regarding what is the reputation of a specific entity. And of course, we also share this information in Rabbit MQ. This is just a small set of the technologies that we use inside the reputation system. So just to show you that this is somehow complex. So mainly I have here picture, let's say in this part, so this is an additional component which is not an interpretation system, but which which we interact. So the blockchain, it's a permissioned blockchain, and we use the project uses a Hyperledger fabric. Inside the reputation system, for instance, we use Redis mainly to keep some data structures, some information regarding the scores of the entities. So also to allow us to determine the score, because when we are updating the score after receiving some events, we also need to take into account the previous scores. So the previous reputation score that was determined. Then we also, and just to highlight some, we also use Spark mainly to have an efficient data streaming processing inside the component. So and the reputation system is implemented in Java technology. Then we have also, let's say, visualization components, which we will show later on, that are mainly based on Node.js and React. If we want, let's say, to have this working, so how this can work? So what is required to put the reputation system working? First of all, we need to specify policies. And these policies, we mainly support two types of policies. So policies for the authorization. And giving a simple example, if the reputation score is low, then the device, for instance, is not authorized to connect to the network. Or the device can connect, but the connection will be, let's say, struggled. So we'll have limited bandwidth, for instance. Or, for instance, we have the reputation of a specific device, and the reputation goes down specific points. So, for instance, it was high, and then it gets the value low. And we need to be sure what happened with the device. And for instance, we also have the policies for the station. And the example that I was providing, when the reputation goes down from high to low, we can trigger, let's say, an attestation requesting, please validate the status of this device because the reputation was low. And another aspect that is related mainly with the reputation system is processing the information that we receive from several components. So, for instance, coming from the attestation, coming from other components like the device behavior monitor, and other components that we have in the project. And of course, and then we share the reputation scores. So for the first step, what we have is mainly, let's say, the policy manager that has a graphical interface. So where the user fills, let's say, a set of fields regarding the policy, mainly the minimum and the maximum in terms of the reputation scores that can be applied, the action that, for instance, should be applied, and this means, should we allow this connection? Should we deny, or should we limit this? The specific identifiers of the devices which are relevant. And for instance, also, let's say, if the device is downloading or uploading, we can also apply the policies distinctly. We also have, besides having this graphical interface, we also have REST APIs. Processing the events at the reputation system is mainly, and these are just some examples where we need what? First, we need to be aware of the policies that were configured by a specific user or by, let's say, organization. And why? Because the policies have a set of fields which, for instance, detect, for instance, the range of the reputation scores. So when we are formulating a specific score, we need to do the mapping. So which policy applies given that we have this device and a specific score. And then the main difficulty, and João can prove it, is that we receive information from different components, which have different structures, different fields of information, and we need to parse all of them. So to make meaning in terms of, is this a good event, let's say an event that contributes to good reputation, or an event that contributes to bad reputation. And this is mainly, let's say, for instance, a message uh, saying, for instance, that a specific device was not authorized. So this, let's say, is an event that contributes, let's say, negatively to the reputation. This is just a high-level overview on how the information flows in the reputation system. So first of all, we use a communication it's based on RabbitMQ to exchange this information. Then we look if, for instance, for a specific entity, if it is a new one, or if we have already information about it, and then we will do all the processing, mainly checking which reputation policies can be applied, determine the reputation score, and so on. And we also store, let's say, this information internally because we need to, for the visualization component, we also need to have this information so that we can also visualize it. Sharing the reputation scores, it's mainly doing what? It's mainly sharing the current score. So how good, let's say, the device is now, how good, so which score, because the reputation score varies between 0 and 1, and 1, let's say, is a device that we fully trust, so has the highest reputation, and the value 0 correspond, let's say, to the lowest value of reputation. And we also have, let's say, we also announce the previous score. And depending on the type of event, we can also provide information regarding the policies that should be applicable to that specific score. And we share this, let's say, this information regarding the reputation scores in the blockchain and through RabbitMQ, so in specific exchanges that subscribe to this information. We also felt the need, if we are dealing with trust, with the reputation, to give some transparency regarding what the reputation system is doing. So for a specific user or for a specific organization to understand what is happening with the different devices in terms of reputation. And that's why we felt the need to have a graphical user interface, so a visual component that could show what is happening with the reputation. And on this regard, we mainly wanted also, let's say, to allow some functionalities. So how the reputation is changing over time, how we can provide this information in appealing and informed fashion. And for instance, we try to gather knowledge regarding the approaches that were being followed in the state of the art. And we use it parallel coordinates, for instance, with three axes. So one of them representing, let's say, the date, another one representing the action type. So where we could see that if it is a negative or a positive event, and then how it would be classified. And this, for instance, allow us for a specific instance of time, according to the information of the event that we receive, to check how it was classified. I now pass the floor to João, which will demonstrate us the functioning of the reputation system.
Okay, thank you. So this is going to be the demo for the part of the reputation system. So we built a Python producer, which is going to send some information into the system, and we will the system will process the data. So policies, this policies are stored in this. We're going to create a mine at the SSI exchange. Then we're going to create events from bearing in mind that some events have severity factoring, so it will affect in the more we will see in the graphical elements of the user interface. So finally, in the end, we are like Sergio and Ruben talked. We send in every single initialization of each entity, we send a attestation request, and we after the calculation where they talked about previously, we receive the attestation result and calculate the reputation based on that. So for the graphical interface for the data visualization platform, replace a previous slide. In the page, some here we see every that every the for we can the entire of the history of the all the system, the total percentage, mean, the maximum and minimum of the reputation system through each type of entity. So now I'll pass the word back to Bruno.
So just concluding, at this stage, we are finalizing the integration. So, and this means that we are finalizing how we process the information that we receive from different components, and just to also keep in mind that the reputation. So we consider this as a crucial measure regarding trust and trustworthiness for internet and for future services, and we need always some mechanisms that allow us to evaluate this in objective fashion. And that's why the models, the reputation models and so on, are very relevant, because they allow us to quantify this this level of trustworthiness. And that's it.
Thank you very much.